Welcome to Rges Pre-Algebra. This is Lesson 9B, and we're covering 2.5 and 2.6 in your textbook. This has to do with measurements with time. We know that we go from seconds to minutes to hours to days, and I'm sure that you're familiar with all of those. 60 seconds are in a minute, 60 minutes are in an hour, 24 hours are in a day. Now, 7 days are in a week. Now, we can also go to year. We have 52 weeks in a year, approximately, and also 365 days in a year. So you can memorize all of these conversion factors if you're not familiar with them on page 81. So make sure you know these time conversion factors. There's one more day in a leap year. There's 12 months in a year. So we can talk about weeks in a year. We can talk about days in a year. We can talk about months in a year. Months in a year. We can talk about decades. There's 10 years in a decade. We can talk about century. There's 100 years in a century. And we can talk about a millennium. There's 1,000 years in a millennium. So memorize all of those if you don't know them already. Now, as far as our conversions go, they're the same thing we've been doing all along. If we're converting from days to weeks, we have to ask ourselves, which is the smaller or the bigger? A day is smaller than a week. So the week would be larger. So we're going to have less weeks than we're going to have days because it's a larger unit. And so we'll have to divide by the conversion factor from days to weeks, which is 7. Okay. If we had centuries and we want to go to years, which is larger, a century or a year? A century is larger, a year is smaller, so we're going to have more. So we're going to have to multiply. And how many years are in a century? 100 as well. So just realize how you're thinking. You're thinking the same way we've been thinking all along as we've been doing these measurement conversions. Now, also they talk about time zones. Now, I'd like you to know the time zones for at least the United States. We have the Eastern time zone, then we have the Central, then we have the Mountain, and then we have the Pacific, and then we have the Aleutian, where Alaska is, and the Hawaiian Aleutian, which is where Hawaii is. But across the continental United States, we are here in New Mexico. New Mexico is a mountain time zone. So if I'm moving or calling a friend who lives in New York, let's say, they are going to be 2 hours ahead of me. So if it's 9 a.m. here, it will be 11 a.m. there. If I'm calling somebody who lives in California, let's say, they will be 1 hour behind me. So if it's 9 a.m. here, it's behind, not behind. So it would be 8 a.m. there. So make sure you understand this concept of time zone. I'm not assigning the problems for time zone on page 83, but I could expect to ask you a question if it is 9 p.m. in New Mexico. What time is it? In California. Okay. And I would expect you to know that it would be 1 hour earlier, or 8 p.m. I could also ask you, what time zone is New Mexico? And that would be the Mountain Time Zone. Or what time zone would be New York? And that would be the Eastern Time Zone. So have some familiarity with that. I will not give you a map, but I'll only ask things that are obvious to you or tell you what time zone it's in. Okay? Let's see, more things to go over in this chapter, 2.5, or this section. Let's look at your problem solving on page 82. The first one says, Mr. Daniels left New York to travel by car to Washington, D.C. He left at 2:15 p.m. And he arrived at 11:50 p.m. So this is problem number 1 in the problem solving. And it asks, what was his travel time? So when it asks travel time, we're actually asking for the number of hours he's driving or flying. So we're not taking into account time zone when we think of travel time. So all we would do would be to take the 10:50 and subtract 2:15. That would be 9 hours and whatever. You can do that, okay? Don't forget that you would have to borrow when we're subtracting. We'll be coming to that. I'll be showing you that later. So don't worry about that quite yet. Okay, number 2 on the problem solving says, the sun rose at 5:47 a.m. and it set at 6:03 p.m. And it says, how long was it shining? So what's the difference between that? Now, recall that if we go from 5:47 a.m. to 5:47 p.m., that is 12 hours, right? And so that'll be a hint for how you figure that one out easily. So let me take a look if there's anything else I want to discuss here in this section. No, so going on to the next section, 2.6, we're talking about speed now. And speed's a very important concept, and you can base your familiarity with this on simply your awareness of driving in a car. Okay, I know you don't drive yet, but you know how we talk about speed in a car. We talk about miles per hour. Okay, that means miles per, I'm having trouble writing, hang on. So mph means miles per hour, or that means how many miles for every hour on an average. Or we could say miles divided by hours. So there are several things I could ask you to find. I could ask you to find the speed. And simply to find the speed, I'm using this definition. If I know the number of miles, I would take my miles and divide it by the number of hours. Okay. So let's say I knew that it took me 180 miles. I went 180 miles, and I went 180 miles in 3 hours. So you're kind of thinking to yourself, well, how many miles did I go in 1 hour? Per hour is the same as in 1 hour. So that should be fairly obvious to me that I would need to divide. And my answer would be 60 miles per hour. Okay. So finding speed would be one thing you could be asked to do. The second thing you could be asked to do would be to find the distance. If you're given the speed, how many miles per hour you're going, so you take your speed and you multiply it by the number of hours. So I'm going to ask you to understand all 3 of these concepts I'm going to go over here. So let's say I'm going 50 miles per hour, That would be my speed. And I am going that way for 7 hours. So if I ask you how many miles did I go, I would have to multiply 50 times 7 and get 350 miles. Now the third thing I could ask is find the time. So if I am given the fact that I'm going, let's say 40 miles per hour, and I have been doing that for, and I've traveled 200 miles, how long did it take me? Well, I would take the distance and I would divide it by the speed. And hopefully all of these things are logical to you. And I would really take some time to think about it to make sure that it is. And so in this case, I would take 200 divided by 40. I'd cancel out my zeros. 4 goes into 20. It would take me 5 hours. Okay, so these are the 3 types of problems you can have with speed. Okay, finding the speed, finding the distance, finding the time, defining speed. Speed, well, our basic formula, I guess, would be distance equals speed. Okay. No, actually, that's, I'm trying to think which one I want to teach you. Hang on a second. Distance equals rate times time. I guess that's a good one. Okay. This would be rate or speed. But learning the 3 approaches I've showed you above are what you need to master. Now, the last thing we can be asked to do is to convert one kind of speed to another. Now, what do I mean by that? Well, let's say I'm going 60 miles per hour, and I want to convert that to feet per minute. Okay. This is not that hard. How would I convert miles to feet? I'm going to have more feet, and I'm going to have to multiply by 5,280, because there's 5,280 feet in a mile. How would I convert hours to minutes? Well, there are going to be more minutes. And how many more minutes? For every hour, I'm going to have 60 minutes. So I would have to take my original number here, multiply it by 5,280, because that's in the numerator, and then divide it by 60. I've got this as a multiply because to go from hours to minutes, I'm multiplying, but I'm going to actually divide the number because it's in the denominator. Okay. Miles over hours. Okay. So let's say, what if I wanted to convert, let's see, 40 miles per hour to feet per second. Well, again, in the numerator, this conversion here would be multiplying it by 5,280, and this conversion here would be multiplying it by 60 to get to minutes, and by 60 again to get to seconds. Now, what would I do with my 40? On a calculator, that would look like 40 times 5,280. Take that answer, divide it by 60, because it's in the denominator. Take that answer and divide it by 60 again, because this is also in the denominator. Okay? So there's a few other ways I could explain that, but I think that's probably going to be the most efficient way to understand it right now. Hang on. Okay, I think I'll just stay with that explanation for now. Later, as we work with more units, we might expand that kind of thinking. Now, in their explanation, they will go back to 3 different formulas based on this one here, but I would rather you just, for this speed, just understand these 3 concepts logically so that you can know what to do, whether you're asked for speed, distance, or time.